Hello everybody. Today's lecture on string efficiency and also dynamic characteristics of the SCRs, unequal dynamic characteristics, nothing but voltage distribution, unequal voltage distribution of two series connected SCRs. About string efficiency we discussed in the previous session. Now here, whenever if you connected two SCRs in series, whenever two SCRs are connected in series, therefore there is a voltage distribution. Nothing but if any high voltage requirement is applicable, wherever high voltage requirement is applicable, here itself voltage requirement about the whenever high voltage is to be required, there itself we use number of SCRs connected in series. Actually, here next the next topic we are going to discuss about the whenever if you any SCR is connected in series. Previously, I told about that for all the SCRs in practical, there is no VA characteristics equal. Must and should be the VA characteristics should be equal whenever this is possible. Therefore, there is a possibility of equal voltage distribution. Equal voltage of distribution. But here in practical, there is no possibility of getting that all the SCRs are having the same VA characteristics. Same VA characteristics. Therefore, we have to make a connection of the circuit, that is equalizing circuit. That is, we are designing the resistance value for the SCRs which are connected in series of a common resistance value. Resistors are placing in parallel to the SCRs. Therefore, with respect to the resistor placing in parallel to the SCRs, we observed in the previous session also, this is nothing but the equalizing circuit. Therefore, while making this type of connections, the voltage equalization, therefore, what about the SCRs having the voltages are equalized? Therefore, there is a possibility of a voltage distribution in equal manner. There is no unequal voltage distribution. Okay. Therefore, what happens? What happens if there is a unequal voltage distribution? What happens means if having that unequal voltage distributions means suppose in this SCR having that voltage distribution of a total suppose 40 volts. We are applied the string voltage of VS is 40 volts. When we are getting this voltage drop across this, here should be 10 volts V1, here 10 volts, totally 10, there is no problem. That is a equal voltage distribution. But what happens? Unequal voltage distribution means the voltage levels should be changing. Here we are getting 9, here 11, here 11 again 9. What should be happen? This 1 volt or 2 volt draw difference means that is called as unequal voltage distribution. There is a problem of SCR getting heating. Why? Because the current values are changing with respect to the voltage and also the current values are changing. Therefore, what should happen means there is SCRs are getting that heat, temperature of that particular SCR are changing. Okay, that is the problem for unequal voltage distribution. Next, this is the resistance value which we calculated in the previous session of equalizing circuit. For the equalizing circuit, the resistance value is to be like this. Next one, what happens whenever unequal dynamic characteristics are observed? If you observe in the circuit, within the circuit, here voltage, the two SCRs are connected in series. First SCR and also second one, and the voltage, the string voltage is has been separated with Vs by 2 and again Vs by 2. Okay, here if you observe at the turn on time period and also the turn off time period, the unequal voltage distribution for two series connected SCRs during turn on and turn off must and should be these characteristics are observed. Why? Because we are operating, suppose if you go any substations of high voltage 220 kV, or it should be a 110 kV, like it. Okay, this much value high voltage substations you are visiting means, if you observe, there is also some switches, there is also some switches which are operating with the circuit breakers, operating with the relays. Here these are the supplies which are moving towards the nothing but the controls of these switches, nothing but the controls of these relays, circuit breakers are have within the panel room. Within the substation there is a panel room. Within the panel room these are all are placed. Okay, nothing but some kilovolts, or it should be 100 volts of rating switches, IGBT switches or MOSFET switches, like the switches are operating. These switches are must and should be required turn on and turn off. Nowadays, if you the main application is to be BLDC motors, vehicle transportation, electrical vehicle transportations are increasing so and so. Here, what should be happen means these all the motors, brushless DC motors are operating using a power drive circuit. Power drive circuit. This power drive circuit consisting of these IGBT switches, that is SCRs or whatever it may be. Okay, these thyristors or SCRs or IGBTs, some of the applications are MOSFETs also are facing. Most of the applications IGBTs. Okay, these switches are using, but these switches are having that control terminal, that is a gate terminal. Okay, switches are turn on and turn off happening. If you observe, if you observe here, the unequal voltage distribution, here the string voltage, first waveform, the string voltage, this is nothing but a turn on. Okay, turn on. Here if you observe, string voltage means the total voltage across the two SCRs. Anode voltage means, here if you observe, only one SCR across voltage, Vs by 2. But here we are observing that the Vs value of this much value. Okay, this much value having that, here T1 and T2 are observing here. If you observe, the T1 and the T2 are the time periods that are considered when turn on process, at the time of the turn on process, and after the turn off. This is turn off. Okay, here it should be getting turn on. Okay, here if you observe, the series connected SCRs have unequal voltage distribution during the transient conditions. Transient conditions are nothing but the turn off and turn on and turn off, and high frequency operation. The frequency range should be very high, high frequency operation. Okay, next, if you observe, the turn on time of SCR2 is more than the SCR1. The turn on time period, if you observe, the turn on time period is more than the turn on time period of the SCR1 by, with a change of dynamic time delta dt. Here if you observe, this is nothing but the, okay, delta td. Here the SCRs are having that first SCR and second SCR. If you observe, what I'm telling, that if you observe, the turn on time of the SCR is more than that of the SCR. Why? Because if you observe, first SCR, here the supply is given. Okay, not here. If you observe, SCR2 is after the first one. First one is here and next one is here. If you observe, Here anode voltage, here cathode. Again here anode for the SCR2 cathode. But here initially the supply is given here. Therefore it should be turned on. First it should be turned on. Therefore turn on time is more for the SCR2. Okay. Therefore the voltage, whatever the voltage, string voltage is shared by the two SCRs is to be Vs by 2 and Vs by 2. Okay, here both the SCRs are gated at the same time. Gated means here this is the gate terminal. Here if you observe, this is the gate terminal. This is the gate terminal. With respect to this gate terminal, and first one and second one SCRs having the gate terminals, these two gate terminals are gated, nothing but giving signals or the pulses to with respect to SCRs is to be at a same time. There is no change in the time. Why? Because two SCRs are turned on at the same time period only. That's why the gate controls can be giving signals to pulses towards the SCRs same time. Okay, here the SCR1 has less turn on time. It gets turned on at instant T1. That is nothing but this one. The SCR1 has less turn on time. If you observe within the string voltage, T1 is the turn on time period of first one. That is nothing but this one, and this is second one. Okay. Here at the same instant T1, voltage across of SCR2, if you observe, will boost from Vs by 2 to almost full Vs. That is nothing but Vs by 2. Actually, here Vs by 2 has been observing. The anode voltage of the thyristor 1, if you observe, this is the one. Vs2 here. Vs2 will be boost up to Vs. Nothing but Vs1 has to be approximately equal to 0. Okay, at the time of the switching on. Therefore, at the same instant of the T1, if you observe at the same instant of the T1, Vs1 and Vs2, if you are observing. Therefore, the voltage shared by two SCRs are unequal. The voltage sharing by the two SCRs are unequal. After instant T1, voltage Vs across SCR2 here T1. After T1, the voltage across SCR2 may turn it on in case Vs is greater than its breakover voltage. Therefore, SCR2 will however get turned on at a time of T1 plus delta Tt. That is nothing but this one. T1 is the time period. This is the time period T1. This one. Delta Tt is the change in the dynamic time period. That is nothing but second one. Okay. Therefore, T1 plus delta Tt. That is the difference. Okay. If you observe, if you come across the turn off characteristics, during turn off of thyristor characteristics, it have assumed that less turn off time, which are shown here TQ1, TQ2, TQ1 and TQ2. Okay. Here, if you observe, this is voltage and also this is the current. Initially it is the nothing but when turn on. Therefore, the two SCRs are having the signals shown here like this. Okay. During turn off thyristor characteristics, here observing SCR1 is assumed to have less turn off time. This is the less turn off time. If you observe TQ1 for SCR1, this is the SCR1. Okay, TQ1 is the turn off time. If you observe the TQ2 for SCR2 is the turn off time is to be more. Okay, why these are the occurring means? If you observe here, the SCR2 TQ1 is less than TQ2 at instant T2. If you observe, this is the T2. At instant T2, SCR1 has recovered and is passing through zero voltage. SCR1 has recovered and is passing through zero voltage. whereas SCR2 is developing reverse recovery voltage. That is reverse recovery voltage means this one X, reverse recovery voltage. Again, it should be coming upwards, okay, up to T2. Okay, here at instant T1, both SCRs are developing. At instant T1, both SCRs, nothing but if you observe on anode voltage, both SCRs are developing different reverse recovery voltages. Whenever it should be coming towards the negative side, here there is a reverse recovery voltage. This is towards the negative side. Therefore, reverse recovery voltages given by AB. This is nothing but the A and this is nothing but the B. If you observe, okay, A, B, reverse recovery voltages. Okay, here, therefore, the turn off characteristics are having that as suffering, nothing but suffering means first SCR turn off time is to be this much time period, second SCR turn off time is to be this much time period. Nothing but what should be happening means the turn off time period should be changing for the two SCRs. Turn on time is also somewhat different, but turn off time should be very much different. That is called as a unequal voltage distribution during their turn off processes. Okay, therefore, if you observe, actually, if you observe for the equalizing circuit, a static voltage equalization circuit, here a complete static voltage equal, we are maintaining that nothing but why we are connected a static equalization circuit means to equal the voltage distribution during the turn on and also the turn off process. Voltage, static voltage equalization, which brings the SCR1 voltage distribution equal to V1 suppose, and V1 V2, SCR2 V2, V1 is equal to V2, therefore equal voltage distribution. But here not happening like that. Okay, here if you observe that the equalization circuit completely cannot maintain that static voltage value, static voltage equalization or a voltage distribution. When it should be not means under sorry, during transient conditions, during turn on and turn off conditions. Yes, all the SCRs are continuously turn on and turn off process are happening there. Here, if you observe, this is the problem that is occurring at transient conditions only. That is a turn off and turn on process only. Okay. Here, if you observe, during the turn on and turn off, the capacitance of the reversed biased junctions determines the voltage distribution. That is how can that it can be told means here. If you observe, that is this is the reverse recovery current. If you observe, if you observe this one within the circuit of reverse recovery current, here if you observe SCR1, SCR2, and this is the equalizing resistance R value has been connected. If you observe another circuit also, we added that is a capacitance value and also capacitive resistance, and an extra diode has been placed here. Why this much circuit has been added means here during the turn on and turn off processes, the capacitance of the reversed biased junctions determines the voltage distribution across SCRs in a series connected string. What I am telling that there is a problem at the turn off condition and also the turn on condition. Here during the reverse biased conditions, reverse biased junctions, okay, there is a capacitance can be exhibits. Okay, that here that it can be shown here within the circuit. This is the capacitance and also capacitive reactance. Sorry, this is capacitive resistance here, which is shown here. Here, if you observe, this capacitance has the effect of removing the inequalities in thyristor self-capacitance. The capacitance has the effect of removing the inequalities in thyristor self-capacitance, or if you, it can be discussed about like this: during turn on and also the turn off time periods, the resultant of the shunt capacitance, this is nothing but a shunt capacitance, and also self capacitance of each SCR, okay, and tend to equal for each of the SCR, series connected SCRs, nothing but the shunt capacitors play a dominant role in equalizing the voltage distribution. Nothing but these are the capacitors which have to play an important role to make it into equalizing the voltage distribution for all the string across the series connected SCRs during the turn on and turn off time periods only. Okay, here if you observe, this is the circuit. The reverse recovery current is to be moving like this. If you observe, during the turn on, turn off, during the turn off process only, during the turn off process only, the current is to be moving towards this like this. Okay, and if you observe, a capacitance has been placed here, shunt capacitance. The current is to be moving like this, and it should be moving backward. That is nothing but the reverse recovery current. Okay, normally it is a this is a static equalizing circuit. This is a static equalizing circuit. Okay, and what is about this one? This is nothing but the dynamic equalizing circuit. Dynamic equalizing, static equalizing circuit, that it once if the SCR is turned on, suppose two SCRs, two series connected SCRs are operating. If suppose two series connected SCRs are operating, means under static voltage equalization circuit, once it is turned on, therefore up to the turn off time period, nothing but the interval between the turn on and turn off time, it should be very high, more. Therefore, under these conditions, we are preferring that static voltage equalizing circuit. But under dynamic conditions, that is nothing but transient conditions, under transient conditions, during turn on and turn off process, therefore we are connecting this type of circuits, that is called dynamic equalizing circuit. This is nothing but the dynamic equalizing circuit. Okay, here a diode is placed, and also the diode is placed, and also an RC value. Okay, the resistance which is used for bypass the high currents, R suffix C, which is the protector from the high current values. Here, during charging time of the capacitor C, when forward voltage appears across this one, now it is a forward biased, actually this one, when it is forward biased, therefore with respect to the forward voltage appears, the diode bypasses the RC during charging time. Okay, this makes the capacitor more effective in voltage equalizing. Here, a limiting of dV by dt across the SCR. Nothing but there is a change in voltage with respect to the change in time during turn on and turn off time periods. Voltage value we observed in the diagram also. We observed that within the diagram, the voltage values has been changing. If you observe the anode voltage here during the turn off time period, therefore what should be happen with respect to these conditions? Here within the circuit, the thyristors here during the transient conditions of against the dV by dt ratings, dV by dt, there is a change in voltage. Therefore, to limit this much value, nothing but delta TD, turn on time period, will occurring. Therefore, voltage change in voltage is also occurring. Okay, at the turn on time period and also turn off time period. We actually, to limit this change in voltages, that is nothing but unequal. Therefore, whenever the voltage has been limited, dV by dt has been limited, means there is a equal voltage distribution. That is about the topic related to this dynamic and also the static equalizing circuits of a series connected SCRs. Here, if you observe, again we can discuss about the flow of reverse recovery current. If SCR1 recovers first, or if SCR2 recovers first, for suppose. Here, if you observe, this is the problem which we are getting: the existence of reverse recovery current. The existence of a reverse recovery current, which we have shown in the diagram. This is the reverse recovery current at a turn off time period. Therefore, what should happen here? During the turn off processes of series connected SCRs, there is an existence of this reverse recovery current. Here, in series connected SCRs, voltage unbalanced during turn off time is which is the more dominant value, then it's during turn off time, turn on time. Okay, why? Because we observed in the waveforms also, turn off time is having that more value compared to the turn on time. Therefore, the choice of capacitor is based on the reverse recovery characteristics of SCRs. We must and should be study about the reverse recovery characteristics of the SCRs also. Here, a capacitors has been placing here for the dynamic equalization circuit. The capacitors, while choosing the capacitor, the choice of the capacitors which we are choosing here is to be based upon the reverse recovery characteristics. Okay, here SCR1 is to be assumed to have short reverse recovery time as compared to the SCR2. Short reverse recovery time. Why? Because why? Because SCR2 is whenever current is to be moving towards the second one means, therefore SCR2 is to be first one. Therefore, therefore, what happens? The SCR1 is assumed as short recovery time as compared to the SCR2. Therefore, here if you observe within the diagram, this one, variation of the reverse recovery characteristics for two SCRs. This is the second one is second SCR, and this is the first SCR. Here there is a charge within the capacitors we are placing here, but there is a charge under reverse recovery conditions. Reverse recovery charge, that is nothing but the reverse recovery charge, which is denoted with the charge in between the SCR2 and SCR1. That's why this is called a delta Q, change in the charge, reverse recovery charge. Therefore, the reverse recovery charge of the two thyristors of 1 and 2, if you observe, SCR1 recovers first, that is nothing but shown here, and SCR2 next one. Okay, SCR1 recovers first and it therefore goes into blocking state and does not allow the passage of excess charge. If you observe, the SCR1 first should be recovers and doesn't allow any charge furtherly. Okay, therefore after that it should be moving towards the SCR2. Okay, SCR2, that is the difference. Okay, here if you observe, this is nothing but the total area of the reverse recovery charge of the two SCRs. This is nothing but the about the reverse recovery characteristics. And next we go for the parallel operation. This is also very much important. Previously we discussed about the parallel operation, but we didn't explain any derivation also. Therefore, if you observe for the parallel operation or the series operation, if you go for a series operation means, therefore for high voltage demand. If you go for a parallel operation means the requirement is to be for high current. Wherever the high current application is to be useful, therefore there is a possibility to connect two SCRs in parallel or furtherly any number of SCRs. If you observe, when current required by the load is more than the rated current of a single thyristor, then we go for the SCRs are connected in parallel. That is also a string. Okay, string. For equal sharing of the current,